Hi, welcome to today's Ed Puzzle. So today we're going to do two things. We're going to review sketching angles just for a little bit, and then I'm going to finally show you how to convert from degrees to radians or radians to degrees. So if you are in the period 4 class, this is from section 6.3. If you are in the period 3 or period 8 class, this is from section 4.1 in your textbook. It's a little throwback. Okay. So what I'd like you to do is take a moment, please, and sketch the angle 240 degrees. Sketch the angle 5 pi over 6. Okay, and go ahead and sketch, we'll go over these in a minute, but go ahead and sketch negative 280 degrees and negative 7 pi over 4. Okay, so for 240 degrees, you should be in quadrant 3, and you should be closer to the y-axis than you are to the x-axis, because you're only 30 degrees from 270, but you're 60 degrees past the 180. 5 pi over 6 is in radians, so I labeled up here pi over 2 and pi. This would be 3 pi over 2 and so on. Since we're going in the positive direction, we go up, which is counterclockwise. I changed my denominator to 6, and I saw that 5 pi over 6 would be in quadrant 2 closer to 6 pi over 6 than it is to 3 pi over 6. So you should be closer to the x-axis than you are to the y-axis. And just to note, here I showed my initial side by tracing over the positive x-axis and showing the little arrow. And I showed my terminal side and put the little arrow on the end. Do you notice here I didn't sketch quite as much? I didn't bother to trace over the x-axis and put the arrow for the initial side, and I didn't bother to put the arrow on the terminal side. It's okay with me if you stop doing those details, but you do need this arc and arrow. That is very important part of the sketch, okay? And then for the other two, we have negative 280 degrees. Since we're going in the negative direction, we're going to rotate down from the initial side, which is clockwise. Negative 90, negative 180, and 270 is up here. So we're going to go a little bit past negative 270. And then for negative 7 pi over 4, remember for your negatives, this is negative pi over 2, negative pi, negative 3 pi over 2. And you have to go past negative 6 pi over 4, but not quite to negative 8 pi over 4. So you should be smack dab in the middle of quadrant 1 for this one. Okay, so that was a quick review of sketching angles. That skill, we haven't seen it in a little bit, but it's going to come back and be necessary in the work that we're going to do next week. The next thing I want to show you is I want to show you how to convert. So if you want to convert from degrees to radians, there are different ways to do this, and there are shortcuts. And I'm going to show you some shortcuts in a week or two. But for now, I'm just going to show you the formal way that works every single time. If you want to convert from degrees to radians, what you're going to do is you're going to multiply by a conversion factor. And that conversion factor is pi over 180. Okay. And if you want to convert from radians to degrees, then you're going to multiply by the reciprocal of that. Multiply by 180 degrees over pi. All right. And let's go ahead and see how that works. So we're going to use this example first. So this is degrees. We want to change to radians. So what we just wrote down is that we're going to multiply by pi over 180. Now here's why that works, and here's how you're going to know to select that. Because one of the tricks is, do I pick pi over 180 or 180 over pi? Okay. So first, the reason we're allowed to multiply by pi over 180 is because this is a fraction that's equivalent to 1. Okay, because if you think of the angle 180 degrees, that's halfway around the circle, so is pi. So this is like in your science classes when you use 12 inches and 1 foot, or you use 1 minute and 60 seconds. Those are other conversion factors you should be familiar with from science classes. And those are all equivalent to 1 because 12 inches is the same as 1 foot. And 1 minute is the same as 60 seconds. Okay, so that's why you're allowed to do this. And then the reason it's going to work is because you have degrees. See, if I put this over 1, you have degrees in the numerator and degrees in the denominator. Those units cancel just like numbers would reduce. So what you're going to be left with is radians. So all we need to do is simplify 240 pi over 180. And I know those are big numbers, but you can just chip away at them. You don't have to find the greatest common factor of them. So I see that 10 goes into both. So I'm just going to cross out those zeros. That's how I'm going to start. Now at this step, you might see that 2 goes into both. I'm not sure what you'll see. So I saw that 2 goes into both. So that's what I did next. So I reduce by 2, and then I saw that 3 goes into both. So I'm going to get 4 pi over 3 as my final answer. So back here, if you recognize that 6 goes into both, you could be a little more efficient than I was, but it's not a big deal just to chip away at it. Okay, so you don't have to find the GCF. You don't have to look at this, and I guess it would be 30. Nope, it would be 60, sorry. 60 goes into this 4 times, and 60 goes into this 3 times. You don't have to look at that and figure out that 60 goes in, right? You can just divide by 10, divide by 2, just keep dividing until you can't divide any further, all right? So that's 4 pi over 3. You can write radians if you want, and that's what 240 degrees is in radians. All right, let's take a look at 5 pi over 6. Let's convert that one. So for 5 pi over 6, we want to change from radians. I don't usually write it, but let me write it here, into degrees. So what we wrote down in the notes is we're going to multiply by 180 over pi. Now that should actually make sense, because if you want to cancel out radians, since you have radians here, you want radians of the denominator to cancel out, leaving us with degrees. So that's how you're going to be able to tell if you want to multiply by pi over 180 or 180 over pi. Whatever units you want to cancel should go in the denominator. If you want to cancel degrees, put it in the bottom. If you want to cancel radians, put it in the bottom. Okay, now here we have pi's are going to reduce, and then I have 5 times 180 over 6. You may be tempted to multiply 5 times 180 next. Please don't. You're going to make your life harder if you do that. Because what you're going to do in the next step is you're going to try to reduce. So instead of multiplying 5 times 180 and making a much larger number, why don't you just reduce while it's factored like this? I see that 6 goes into both of these. 6 goes in here 30 times, 6 goes in here once. I can do 5 times 30 in my head. And I kept this a much nicer problem. If we had done 5 times 180 first, what we would have had is 900 over 6. Okay, so it's not wrong to do 5 times 180, but you're going to have much larger numbers, and you're still going to get 150 anyway. So what I would recommend is when you are doing this type of arithmetic, don't multiply those numbers in the numerator, because you're going to try to reduce anyway. All right, 2 more to go. So let's go ahead and convert negative 280 into radians. Since I have degrees up top, I want degrees on the bottom to cancel, and I want radians up top to stick around. So we're going to use pi and 180. So degrees are going to cancel. And you don't have to rewrite it like this. You could actually just start crossing out and reducing here. But I just rewrote it so I could have a little more space. I see 10 goes into both. You could just cross out the zeros, but I went ahead and rewrote. And now I see that 2 goes into both. And that's it this time. Negative 14 pi over 9 cannot be reduced any further. That's fine for the answer. If you want to write radians on there, that's great too. And that is negative 280 degrees in radians. Last one. Negative 7 pi over 4. We have this in radians. I want to get rid of radians, so I'm going to put that in the denominator, and I want to keep degrees, so that's what I need in the numerator for my conversion factor. So 180 is going to go up top, and pi is going to go on the bottom. Radians will reduce out. Pi is going to reduce out. And you can right now reduce the 180 and the 4. If you'd like to rewrite it, you can do that. And then you can go ahead and reduce. So I see 2 goes into both. Oh, and then 2 goes into both again. So I guess I actually could have, from the beginning, I could have reduced by 4, but I didn't see that. So it's okay to reduce by 2 and then reduce by 2 again. So what I have left is negative 7 times 45. That one I'm not going to do in my head. So I'm going to get 28 and add 3. Okay, I get 315 degrees, and just be very careful, because see how this was negative? Your final answer better be negative as well then. And it is, that negative is there. I just kind of neglected it for a moment. All right, but the negative tells us to rotate in the clockwise direction, in the clockwise direction. So if we're trying to convert this and find out the exact same angle but in degrees, then it should still be negative. Okay, and I didn't mention that over here, but notice that this was negative in degrees, and it should be negative when you convert it in radians. All right, that's about it for today's lesson. So today's lesson is how to convert formally. So I call this the formal method because it works every single time. But what we're going to find in the next couple of weeks is we have a lot of angles that show up very often in our coursework. So I'm going to show you shortcuts for those as well. Thanks for watching, guys.